All right, kiddos. So this is going to be our lesson 4-12 instructional video. And it's going to include, 4-1 and 4-2. I'm putting those two together because it's kind of all the same stuff. It's all about piecewise functions. Okay, and this is going to be our intro into them, and then us, practicing them intermediately as well. So first we're going to talk about what are they, obviously. Then we're going to talk about how to graph them. Then we're going to talk about a special kind of piecewise function called a step function. Then we are going to kind of revisit domain and range here in this lesson, and that's kind of the add-on to this, right? So we'll get there. So starting with EQ1, what is a piecewise defined function? So a piecewise defined function, well, we'll get it from this first example here. So in what two ways will f of x, so this is f of x, behave and where exactly, right? So if we create t-charts, right? So if I go from, I don't know, -3, supposed to put x and f. So if I go from -3, -2, -1, 0, 1, 2, 3, right? If I go all the way down, well, we know, so the absolute value of -3 is 3, 2, 1, 0, 1, 2, 3. So the way it's behaving would look like this. It behaves like f of x equals x, or y equals x on the one side here, when x is greater than or equal to 0. And it behaves like y equals -x, right? Because we have a negative slope coming down. It behaves like y equals -x when x is less than 0. And the way that that looks is we could say that f of x is equal to, well, it behaves like y equals x, so we'll just say, so -x if x is less than 0. And then it behaves like positive x if x is greater than or equal to 0. Okay, so what I've done is split the domain, right? I split the domain into pieces, hence piecewise defined. Okay, so a piecewise defined function is basically a function where, let's say where, a function where domain is split, right? And it may be split into 2, it may be split into 3, 4, however many functions. Okay, so you'll see piecewise a lot later in higher math, especially with things like parameterization and things in physics and all kinds of other stuff. Okay, but you get the idea. So let's look at another example. Okay, so how does g of x behave? So g of x, and I'm not going to spend too much time on this, but this is how we would split it. Okay, so g of x is going to behave like this. So negative x plus 2 minus 1, assuming x is less than 0. This should look familiar, like when we were solving absolute value equations on 1-3. That's where I'm getting this from. Or it'll behave as just regular positive x plus 2 minus 1 if x is greater than or equal to 0. Okay? And if I actually simplify that out, so this would become negative x minus 3 for x less than 0, and this would become x plus 1 for x greater than or equal to 0. And what that's going to look like, let's see how good my graphing skills are. So starting here on the positive, just because, so my y-intercept is going to be 1, and it's going to be a slope of positive 1, so it's going to be about like that. Then my slope is negative 1 with a potential y-intercept at -3. Okay, so that's going to end up looking like, well, here, I think I made a goof. So let's look at Desmos and see what it's supposed to look like. Because something's wrong. So if I just type this into x, what was it, plus 1? Oh, it's plus 2. and then plus 2 minus 1. So we see that's what it looks like. That's where I messed up. I messed up when I put my y-intercept here. Because, and we'll learn about transformations here later on, but the reason, so my y-intercept is the plus 1, but it wouldn't be, so my domain is not split at 0. My domain is actually split at negative 2. So let me say this. I should have erased the zeros. Okay, so I'm going to be here at negative 2 for x, and then it behaves like y equals negative x. And if this was to continue, then it would come down here to negative 3, but it doesn't continue because we're splitting it accordingly. Okay, so this needs to become negative 2. Negative 2. Okay, so sketching the graph's not going to go over that. We'll go over that in class. So now we're going to talk about graphing them on our graph boards. And that's just going to entail using T-charts, right? And this is something that we need to go back to because we're really bad at this. And we'll continue to just use from negative 3 to positive 3. So negative 3, right? So if x is negative 3, I'm going to have negative 3 over 2 plus 1. So that'd be 2 over 2, so negative 1/2 would be f. And actually, it wouldn't be negative because we're doing the absolute value, stupid. Okay? So then, at negative 2, we have negative 1 plus 1. So at negative 2, we get 0. At negative 1, we're going to have 1/2. And at 0, we're going to have 1. If I continue down, so positive 1, that's going to be 1/2, so 3 over 2. And then positive 2, that's going to just be 2. Positive 3, it's going to be 3 over 2, 5 over 2. And if you want to use decimals, so 1.5, 0.5, 0.5. This would be, brain fart, 2.5. Okay, so what that's going to end up looking like when we actually graph these points out. Oh yeah, cool. So when we actually graph these points out, make that more pronounced. So if I do 1/2 x plus 1, absolute value, I go ahead and add, why is it doing a table? So negative 3, 0.5, we see a point there on the graph. Negative 2 by 0, see another one, and you get the idea. Okay, so when you're graphing these, I mean, all you're really doing is just making a T-chart and seeing where it goes. And if you know it's linear, right, you can just follow it. So, I mean, we can pretty much already stop here. Okay, so clearly we see this is how we would graph them. Now, this one isn't defined in piecewise as we know it from the previous example, right? So piecewise looks like this. Okay, but we don't have it defined that way. Let's go ahead and define it that way. So, if we were to define it that way, wouldn't hurt to look at the graph, right? So how is it behaving? Okay, so looking at the graph, obviously we have a negative slope to begin with, and we know that we're going to end up with negative 1/2 x plus 1, like that in parentheses, or positive 1/2 x plus 1. Okay, and we know this from lesson 1-3. Okay, so the question is, where does it behave this way? I'll go ahead and distribute the minus, because why not? So where does it behave this way? And I can go ahead and tell you from just experience, right? So this one's going to intersect at 2, okay? So we're going to go ahead and say it behaves this way for x less than or equal to, well, we'll just say less than -2. It behaves positively, positive 1/2 for the slope, plus 1 for the y-intercept when x is greater than or equal to 2. Okay, so that would be how I define it in piecewise. Now let's check and make sure, right? So I'm going to leave these points there, and I'm going to turn this guy off, and I'm going to try something. So I'm going to see if it allows me to do this. So -0.5 x minus 1, and then if x is less than -2. Oh, passes through the point it's supposed to so far. Let's try the other half. So that would be this piece right here. Okay, so 0.5 plus 1 if x is greater than or equal to 2. Oops, 0.5x. What's the matter with it? Okay, so that should be a -2. Whoopsie. There we go. So we see that it works out. It gives us the exact same thing as it did here earlier with this one. Okay, so looking at these other two, and I'm going to go ahead and skip g of x. We'll look at, well, no, I need to not do that. So if you make the t-chart for g of x, so we're here now. So x and g, right? So we'll start with -3. So if x is -3, of course, we're going to be here because that's less than -2, right? So that means we're using this piece of the function. Okay, so -3, that would be 3, plus 2 is 5. Okay, then we're at -2. Well, -2 is not less than -2. It's greater than or equal to -2, right? So that means we're going to use this piece of the function. So at -2 squared, well, that's just 4. -1, that squared is 1. 0, well, that's 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. Okay, and if we look at a graph again, and I don't know why I keep closing it if I'm just going to open it again. But if we look at a graph again, and we follow what this is saying. So -x plus 2 if x is less than -2. Okay, and x squared if x is greater than or equal to -2. Okay, and we clearly see right here, this is what our graph looks like. So let's see if our points match up. So if we actually put the points, so -3 by 5, -2 by 4, okay, -1 by 1. Working so far, 0 by 0, 1 by 1, 2 by 4, 3 by 9. So very clearly, right, if we had just graphed this out by hand, which I'm expecting you to do in class, but on this video, I mean, I can't really have you do that unless you just want to practice on graph paper. But pretty straightforward. Okay, so I'm already at 14 minutes, so I'm going to go ahead and skip this example. But you get the idea. I mean, it's pretty straightforward. Okay, so now let's look at a different kind of function, right? This is called a piecewise function, but it's a step function. So this right here is a step function. Okay, and long story short, so if we graph this, it's going to make steps. So let's make our t-chart. So x, f. So let's start at -3. So if x is less than -3, oh, well, we're not going to use this. Okay, let's back up. Let's maybe not start with, let's start with -5. So -5 is less than -3. So if x is -5, then the graph just behaves as -2. So we're just going to say it continues to be -2 until we get to -3. When we get to where we're equal to -3, that's when it's going to equal 1 instead. So at -3, f is 1. At -2, it's 1. At -1, it's also 1. At 0, it's 1. And I mean, you kind of get an idea of what your graph is going to look like here. So until we get to 2, right? So at 1, it's still 1. And at 2, well, 2 is not greater than 2. It's greater than or equal to 2, right? So now it's going to behave like this. Y is going to equal 3. Okay, and it's going to continue that way. So let's look and see what that's going to look like. All right, so here we've got a pretty clear picture of it. Okay, so what we have are steps. Okay, so now we need to think, what kind of circles would we put on the end of these steps? So here in red, right? So we see here, let me go ahead and zoom in if it, no, it's not going to allow me. If we zoom in here, okay, we're clearly at -3. Okay, so -3, whoops, I need to put table. -3 by -2. So now we have to ask ourselves, should this be an open or closed circle? Well, on our interval, x is less than -3, so we're not going to include this particular point. So it's going to be an open circle. Okay, so if I want to put another point, okay, here at -3 by 1. Okay, so at -3, right, it is equal to 1, so we include -3 with the 1, so we're going to leave that a closed circle now. Okay, then as we continue on, x is less than 2, so we're not going to include it here. So then that means here, on the right end point of our blue step, so that's at 2 by 1, we're going to want to change that to open. Okay, then when we get over here to the green, so we clearly see x is greater than or equal to 2, so this is going to be a solid dot. So I'm going to put another point there, and that's going to give me a point that is solid. Okay, so that is at 2 by 3. We're just going to leave that solid. And what we end up with is this here. So we're continuous, not including -3 here, but we are including -3 here. And we're not including +2, but we are including it here. So our domain is continuous. It's split up, but it's still continuous. The only thing that changes over the domain is the behavior of the actual f, of the y values. Okay. Oh, and FYI, if you didn't understand why that was a step function, come on, man. Pretty clear why it's a step function. Okay. So let me zoom out because this is really tiny for some reason. Okay. So these are functions from the previous example. So really quick, let's talk about their domain and range, right? So domain is basically the possibility of all the x values. Okay, so we're looking at f of x right now, this red graph here. So if we're talking about domain, well, clearly we see the domain continues on and on and on forever. Okay, no matter how far I zoom out, it's just going to continue and continue and continue. Okay, so my domain, one way to put it, so this is for f, right? So one way to put it is using inequality notation. I would say negative infinity is less than x, because we're talking about domain, which is less than positive infinity. Okay? If I'm talking interval notation or parenthetical notation, you'll hear me use that word. I would say negative infinity is my left endpoint, positive infinity is my right endpoint. And I'm going to use curved brackets on either side to represent that I'm not including, I'm not saying or equal to, right? You can't be equal to infinity. Okay, and then set notation. So all I would say here is that we have an x, our domain is an x such that, so that's what this bar means. So our domain is an x such that x is a real number. And you may remember seeing that from Algebra 1. Okay, so that's how I would say the domain. So what about the range? So that was my domain. What about the range? So range is the same idea as domain, except with y. And I have a whole bunch of crap open. Close that. And let's go back to this one. So my range, same idea, except where do I start at the bottom and end at the top? So domain is where do I start on the left and end at the right. Range is where do I start at the bottom and end at the top. So I'm starting here at 0 and going out to positive infinity if I go up, right? So I would say my range is 0 is less than or equal to, because it can be equal to 0, right? So if we look at the graph again, it is actually touching 0 here. Okay, we have a point, -2 by 0. Okay, so 0 is less than or equal to f, which is less than, well, it went on forever upwards, so positive infinity. And then our interval notation would be, and that wouldn't be a curved bracket this time because we're including 0. It would be a square bracket. And then my right endpoint would be positive infinity. And then here, I would say that I have an f such that f is greater than or equal to 0. Okay, so that would be how I would express my domain and range using inequality, interval, and set notation. Okay, so we'll do one more example. I'm going to do this third example here. Erase, give myself some room. Okay, so we're doing h of x, right? So let's look at h of x. Well, I'm not going to memorize this. So this is h of x. Okay, so we're only talking domain and range. Okay, so domain, we're going from negative infinity, it looks like. I'm bolding this. From negative infinity, right? So where do we start on the left? Negative infinity. Where do we end on the right? Positive infinity. Well, let's make sure we're including everything, right? Because right here, okay, well, we're including -1. It's not included here in the red open circle, but it is included in the black closed circle. And then if we look here at 3, right, it's not included on the red open circle, but it is included here. So it's continuous for all x, so that means it's all real numbers, or we would say, so depending on what notation we're using, we would say negative infinity is less than x is less than positive infinity, or interval notation, curved bracket, because we're not being inclusive of infinity. We can't include infinity. And then set notation, and that would just be x such that x is a real number. And I'll go into more detail physically in class. So that's our domain. Our range might be a little more complicated. So where do we start at the bottom and end at the top? So we start at the bottom at negative infinity, and then we continue. Well, then we get here to y equals -2, and it seems discontinuous, but nope, it's included there. Then we pick up back over here, and then we continue up until we get to here, right? So it looks like we continue from negative infinity up to positive 6. Okay, so we would say negative infinity is less than h is less than or equal to, and let me double check. Did we include it? No, we did not include negative or positive 6. So it would just be less than, not less than or equal to. So negative infinity to 6. It's going to be a curved bracket because I'm not including the 6. And then here we're going to just have h such that, and then basically we're going to put our inequality notation again. So negative infinity is less than h is less than 6. Or you don't have to put the infinity. You could just say that h is less than 6. But I know, like for me, it's less confusing if I'm using the infinite symbols, just so I always have an endpoint. So that's it for this lesson. Obviously, let me know if you have any questions. Shoot me an email, come through tutoring. Otherwise, goodbye.